Okay, so we're looking at our old data set that we had created last time about liking math and also looking at SAT math scores. And to talk about missing values, we're going to play around with our little example here. And let's say that some of our respondents didn't want to tell us what they got in their math SAT scores, and they actually had left that answer blank. And let's say that we tell our coders that anytime they come up with a blank, they're supposed to enter a missing value, and we define it as, for instance, 999, which is an impossible SAT score because it really just goes from 1 to 800. So we have two missing values, and we put 999. And it's always a good idea that anytime you're working with a variable, the very first thing you want to do is run a frequency just to see what the values are looking like and what SPSS is treating as a valid value. So let's go ahead and run a descriptive and run a frequency. And we're going to go ahead and run a frequency for both of our variables and put OK. So here we have our both frequency tables for both variables, like math and SAT math. And we see here SPSS tells us on the most left box all the values that are being treated as valid. If you remember from the first video, we said that this was a question that was ranking 1 through 5 how much they like math. We had somebody who got a little bit overzealous and gave us a score of 8, which skews all of our results in terms of valid percent. About if you really were interested to figure out how many people actually put 1, the computer is now telling us 16.7% instead of what it should really be is 20%, because it's treating this number 8, which means nothing, as a valid score. Similarly, we have here on our SAT math score 999 being treated as a valid score, which would also skew, let's say, if you're interested in an average, calculating that average. So let's, for an example of that, let me just show you what the average math score is right now, calculated by SPSS. And to do that, and we'll cover more about central tendencies in a future video, but quickly, if you wanted just to do an average, you just click on the statistics box and we click on mean here, and then we click OK. And you see that in the first little box it actually calculated the mean as 648, which is a really high SAT average for our class, because this 999 is being treated as valid, and actually it shows that 2 people scored extremely well, constituting 33% of the variable. So how do we get rid of that 999? Well, to do that, we go back to our SPSS views, and we go to variable view, and we look at what is being treated as missing in that missing box. So you just double click on that, and currently there's no missing values, and so let's go ahead and put a set of missing values. SPSS allows you to have 3 missing values, and so we only need 1, and put 999, click OK. Now if you run that frequency again, so if you look now at the frequency table that it gave you, you see that SPSS is telling you what it's treating as valid and what is it treating as missing. And this has implication for the difference between percentage and valid percentage, because valid percentage actually excludes the missing values. So whereas before we had only 16.7% of the class scoring 300, we see that the actual percentage, the valid percentage, is 25% of the class scoring at 300. It's because we're excluding this 999 value. And you can see the difference between percent and valid percent in the boxes that it gives you. This percent actually tells you the values including the missing values, and valid percent just gives you the breakdown of the valid scores, excluding the missing scores. And you can see it also has implications for calculating the mean. Whereas before, our average was at, well, a little too much there. our average was 648. Now, excluding 999, our average is 472. Now, we also had some missing values with our other variable, our like math, where we had this score of 8 screwing things up. So we want to get rid of that. So we go back to our variable view. We go to our like math. We simply click on our missing, and we define 8 as missing. Click OK. Now just run the frequency again. We can just click on reset. And you can see again, SPSS is telling us what is being treated as valid and what is being treated as missing. And this changes our valid percent. Whereas before it was calculating that only 16.7% of people said they hated math, we see that excluding the missing values, it's really 20%. It also impacts the cumulative percentage. Now let's look at some of these missing values when we work with the GSS. Okay, so here's the GSS variable view, and let's work with our first variable, our abortion variable, and we can just run a quick frequency on that to see what the values are. We go to Analyze, Descriptives, Frequency, move our variable, click OK, and we see here that SPSS is treating yes, no, and DK as valid, and it's treating as missing non-applicable and no answer. So you see the difference between valid percent and the regular percent because it's excluding these missing values. But doesn't know is being treated as a valid response as well. So right now we have 40% saying yes, they think abortion's okay for any reason, and 60% saying no. But we really don't know what these percentage mean if we're including this don't know variable. So let's go ahead and look at the values and how these values are being defined. We go to the variable view, and we can click on values, and it tells us, okay, 0 is being defined as non-applicable, 8's don't know, and 9 equals not answered. Let's look at the missing values. And we see that only 0 and 9 are being included. So let's go ahead and include the doesn't know as missing as well, which 8. So it was 8, and go ahead and input 8. And now we can just run the same frequency again. And now, in this new frequency table, you can see that the difference is that the doesn't know is now being treated as missing, which impacts the valid percent. Now it's gone up from 39.4% to 40%. So it doesn't make a huge dramatic change because only 50 people marked doesn't know. But if many more people had said doesn't know, this change could have been a little bit more dramatic. So let's go ahead and look at a continuous variable and see how missing values are treated there. And one of the variables you'll be working with a lot is SEI, which is social economic indicator. Here we can look at the respondent's social economic index. And we can see at the values here, these are the missing values, -1, 99.8, and 99.9 should all be treated as missing. And we can make sure that's the case by simply clicking on it. And you see that one of them is not being treated as missing. So we should go ahead and type that in. We can run a frequency for this guy. Click on reset. Now to find this variable, I always click on this menu and then type it out, SEI, and it should lead you right to the variable. Click it over and press OK. So this gives you a long table of socioeconomic index, and you can see here again, just like for discrete variables, for continuous variable, SPSS tells you what's being treated as valid, all these values over here, and what's being treated as missing, which 268 people are missing, and they constitute 6%, roughly 6% of the sample. What, for instance, happens when there's more than 3 missing values? That becomes a little bit tricky. As you can see, there's only 3 values that you can put in for missing. Okay, so if we look at this variable called own gun, we can see that the label is asking if the respondent has a gun at home. And we can see how this was coded, and we see that there's yes or no, so it's a yes or no question, but it actually has 1, 2, 3, 4 values that are actually outside of yes or no. And if we just run a frequency, one of these values is going to be treated as a valid response. The reason that is because if you look at the missing values, you can actually see that it only allows you for having 3 missing values, and only 2 of them are being treated as missing. So the people who set up the GSS treated only these 2 values as missing. So let's look at what happens when you run a frequency. Okay, so looking at the frequency, we go to descriptives, frequency. Okay, so I have my frequency menu, and I can just type in own gun, and it gives me my variable. I switch it over and click OK, and you can see that yes and no are being treated as valid, but so are refused and don't know. And even though it's a small percentage of the population, it's going to affect my valid percent. So let's go ahead and get rid of those guys. And we can't just fix this problem by just going to the missing value, because the missing value only gives us spaces for 3 values that we can input as missing. So what we actually have to do, we have to recode this variable. And there's a couple different reasons why we recode, but this is one of them, especially when there's more than 3 missing values. So we form, and we go to recode into a different variable. We pick our variable that we're going to recode. So again, I can just click on this menu and then type own gun, type it in here, and now it puts me into this little menu that says own gun being transformed into, and we put a different variable. So we got to define this new variable. We're just going to call it own gun _m. We click on change, and now we can see that SPSS knows to change this variable into this other variable. We look at old and new values. Okay, so it gives me a little menu here where it has old values and new values. So here I'm just going to input the values of the original variable and telling SPSS what to do with them. So I know that 0 was one of the missing values, so I go, if it's 0, tell SPSS to treat it as systems missing, and we click on add, and it gives this function that it's going to do. Another variable or another value that was missing was 3, and we treat it also as missing value, as systems missing. Click on add. Another one that was missing was 8. Click add. Another one that was missing was 9. And then we click on all other values. So treat everything else as they were treated before. And so SPSS now has all these commands to change these values into systems missing and to change everything else into its old values. We click on continue, and we simply click on OK. And you can see it gives you the syntax where it recoded this variable, giving these commands, changing 0 into systems missing, 3 is systems missing, 8 is systems missing, and so forth, and copying everything else into its old value. So if you now run a frequency, and I'm going to leave the old variable and also the new variable, which is onGunM, so we can compare both of them. So here we have our two variables. This is the old one and the new one. The same frequencies for yes and no, but now the missing values are a lot larger, and so, or significantly larger, to actually impact the valid percent. So we have 33.7% versus 33.2%.